welcome to the Mercy Fields podcast. I'm Mistaya Wilkes, and this is podcast number 8. This is um, a really monstrous subject that we're hitting today. This is about IVG and IVES. Let's get right into it, shall we? Let's go into describing some of the 3 leading men that are responsible for basically brainstorming this and taking this into a place where they are seeing it come to fruition. And that's Eli Y. Adachi. He's an American physician scientist and reproductive endocrinologist whose career has spanned clinical medicine, academic leadership, and national policy on reproductive technology. He trained first and as an obstetrician and gynecologist, earning his medical degree from Tel Aviv University in 1973, then completing residency at Tufts University in Boston, and a fellowship work in reproductive endocrinology at Johns Hopkins and the University of California, San Diego. Later, he added a master's degree in healthcare management from Harvard. His early bench research in the late 1970s and 1980s focuses on ovarian biology, the growth factors, specifically in enzymes and hormone interactions that regulate follicle development and ovulation. These studies defined molecular pathways that underline many assisted reproduction protocols still being used to this day. Now, by the 1990s, Adachi had become one of the leading figures in American reproductive endocrinology. At the University of Utah, he chaired the Department of Obstetrics and Gynecology and led a broad program combining laboratory research with infertility care. His group investigated how growth factors and proteases controlled folliculogenesis and luteinization, integrating cellular biology with clinical hormone treatment. His work appeared in Endocrinology, Fertility and Sterility, and the Journal of Clinical Investigation, linking molecular mechanisms to the emerging technologies of what we have IVF, then still young in clinical medicine. Mind you that IVF came by way of the UK. And now in the 2000s, he turned increasingly towards policy and bioethics, examining how science and regulation intersects in fertility medicine. When he became Dean of Medicine and Biological Sciences at Brown University in 2004, he used that platform to engage the public on the governance of reproductive technologies. And he was also elected to the U.S. National Academia of Medicine, the Academy of Medicine, rather, in 1999 for his contributions to both research and medical education, and then later received the American Society of Reproductive Medicine's Lifetime Achievement Award back in 2018. Now, what makes Adachi central to modern discussions of in vitro gametogenesis, it's not experimental bench work, but the way he structured the field's ethical and legal conversations. And so this is really the go-to guy right now that is to be interviewed when it comes to these subjects and the subject matter. And so a lot of people are having him on their shows and stuff like that, and doing a lot of talking as of recently, quite a bit more than usual. And then in 2019, he co-authored the policy Stem Cell Derived Human Gametes and the Public Engagement Imperative. And he published in Trends in Molecular Medicine. That paper, written with Glenn Cohen and Jacob Hanna, Azim Sarani, and Gatsushiku Hayashi. We'll get to that gentleman later. They argued that laboratory creation of human gametes demanded early, transparent public discussion rather than quiet technical progress. It outlined foreseeable uses of IVG in fertility treatment, genetic disease prevention, and reproductive redesign, and of course the profound social and legal questions each would raise by that. Even their best intentions is really still demonic. 2023, Adachi chaired the National Academics of Sciences workshop titled "In Vitro Derived Human Gametes as a Reproductive Technology." Scientific, what they deem as ethical and regulatory implications. I would like to state that he actually says that he is very confident in the regulatory safeguards, as he puts it, that are out there, and has, I quote, "It is not a fearful thing to progress in this quickly, if able." That he has full confidence in those guardrails. We know that that's not the case, actually. So that they did this with a 2-day session. They brought it together: stem cell biologists, reproductive endocrinologists, legal scholars, ethicists, a map that has been achieved in animal models, what remains scientifically uncertain, and how U.S. law would classify any future human use. Adachi's opening report summarized the regulatory reality. Any human IVG product intended for pregnancy would be treated by the Food and Drug Administration as a biological therapy, requiring preclinical safety studies and investigational new drug IND applications before even a single clinical attempt could be made. So he emphasized that translation to human reproduction was premature. The policy must move in step with evidence, not speculation. The proceedings published by the National Academies Press became the reference framework of how now that is cited by regulators and journalists alike, both. So in 2024, he and the co-authors at Brown published an in vitro gametogenesis in the ongoing quest to vanquish infertility. The role of epigenetics, a commentary in F&S report that analyzed how epigenetic fidelity will likely determine whether IVG ever becomes clinically acceptable. He also contributed to Journal Assisted Reproduction and Genetics the same year, summarizing lessons from the National Academies Workshop and highlighting the importance of international coordination, echoing the lessons learned earlier from mitochondrial replacement therapy regulation. In 2025, he co-authored Assisted Reproductive Technology in the late 21st century, and Infertility and Sterility, projecting how technologies like IVG and synthetic embryo models might transform reproductive medicine, and emphasize the policy foresight is essential to prevent misuse. Again, across 5 decades of work, from molecular endocrinology to national governance, Eli Y. Adachi has shaped both the science and the structure of reproductive medicine, where Mitanori Sayato and Katsushiko Hayashi built the biological framework of IVG in mice. Adachi built the regulatory and ethical framework that defines how nations discuss and may someday evaluate its use in humans. His leadership in 2023, the National Academies Workshop, stands as the moment when in vitro gametogenesis formally entered the realm of public policy and oversight, not just laboratory curiosity. So together, his scholarship, governance, and advocacy have played a huge part in the next steps in reproductive biotechnology, as it will unfold under deliberate scrutiny rather than surprise, because we have had dealings with that from the medical scientific community years back, where everything was done on the down low. No even public discussion was allowed. So let me state that, as I said, I was going to get to it. So this man is claiming and is applauded for being the man who's bringing the ethics to the table. But we see the world's ability to do that falls short and brings God no glory, because they don't know how. So they have no standard by which they are um, setting their standards of what is and ethical and what is not. Um, so like I said, these gentlemen are probably nice enough people if you were to meet them. Um, I'm sure that they are pleasant and very smart. Um, but the problem is that the world still thinks that embryos are not quite all the way human, and it's still up for debate. It's really quite sad. So let's move on. It's a Mitinori Saito. He is a physician, scientist, and developmental biologist in Kyoto University, where he directs the Institute for Advanced Study of Human Biology, known as ASHBI, the ASHBI, and they just pronounce it ASHBI. In 2011, he and his collaborator, Katsuhiko Hayashi, um, achieved the first reliable conversion of the mouse pluripotent stem cells into primordial germ cells like cells. And so the earliest reproductive precursors is what that was. They began by turning mouse embryonic or induced pluripotent stem cells into short-lived epiblasts like cells, a stage that initiates the gastrulation epiblast of an early embryo. And so within 2 days, those cells responded to carefully timed chemical cues that Sayatu lab designed, and then adopting the molecular signature of primordial germ cells. These laboratory made PGCLCs were then transplanted into mouse testes, where they completed spermatogenesis and then produced functional sperm. That experiment, published in Cell in 2011, proved that the full germ cell program could be recreated outside of the body. And then in 2012, he also, his group extended the same logic to the female side. They combined the PGCLCs with fetal ovarian tissue to build what they called a reconstituted ovary. The hybrid tissue was then grafted under the ovarian bursa of the host mice, and then uh, within these grafts, the PGCLCs erased old epigenetic marks, entered meiosis, and then matured into a recognizable oocyte, which when those eggs were then covered, fertilized, and implanted into surrogate females, they produced healthy offspring. That they full-grown pups is what they got. For the first time, viable animals had been born from gametes generated entirely from just stem cells. So he proved that that was absolutely you're able to do it. And so in 2016, his network had removed even the need of transplantation. His team guided mouse pluripotent cells through every stage of oogenesis, completely in vitro, and the resulting eggs were fertilized, embryos were cultured, and new lines of cells were derived from the pups, closing the entire germline cycle inside of a dish. The Nature paper that year became the technical blueprint for the in vitro gametogenesis, and later, he and his colleagues refined the epigenetic and chromosomal checkpoints that defined quality in laboratory gametes and published the definitive science review Mammalian in Vitro Gametogenesis, and that was in 2021. So it's been going on quite a while. In human work, the same Kyoto Institute reported in 2024 that it could reproduce key phases of germ cell epigenetic reprogramming using human-induced pluripotent cells. These cultures move the cells towards early pro-sperm and pro-egg states with partially correct imprint patterns. And incremental but important step towards human IVG, Altogether, he built the conceptual and technical map for the field of stem cells to epiblast-like cells to germ cells to gametes. Now, Katsuhiko Hayashi, he is now a professor at Osaka University. He transformed that map into full biological reality. He was the first author on the 2011 Cell paper that launched the IVG, demonstrating that the transient epiblast-like stage was the precise window during which pluripotent cells could be directed into the germline cells um, just 1 year later. So Hayashi led the 2012 science study that produced live offspring, the oocytes grown in reconstituted ovaries. His laboratory verified that the engineered oocytes completed meiosis, reestablished correct maternal imprints, and then generated healthy pups when fertilized. And in 2016, the same network completed the process that entered entirely in the culture, showing that follicle formation, oocyte growth, and maturation could all occur in vitro without any animal graft at all. Each stage was timed to mimic follicle genesis, proving that the complete female germline cycle could be reproduced in glassware. Then came in 2023, the year Hayashi's team reported in Nature that they had generated functional oocytes from male mouse cells. They began with XY-induced pluripotent cells and then used the chromosome engineering to delete the Y chromosome and duplicate the X, and thereby creating euploid XX cells. Those programmed cells entered the standard that Sayatsu and Hayashi germ cell pipeline in induction to the PGCLC's aggregation with ovarian somatic cells, in vitro maturation, fertilization, and embryo transfer. A few of those embryos developed to term, producing healthy pups that carried only the engineered male-derived genomes. The efficiency was low. Only a few percent of the fertilized eggs progressed to biocysts, to blastocysts, and live birth rates remained in the single digits. But it proved that sex chromosome barriers could be bypassed and that cellular identity in the germline was far more flexible than once believed. Hayashi has since continued refining chromosomal stability checks, meiotic control, and imprinting accuracy, and he co-authored reviews describing the ethical and translational boundaries of IVG. Together, Sayatu and Hayashi established the framework that every later human cell study still follows. Multi-stage induction from pluripotent cells through germ cell precursors, validated by precise molecular markers, culminating in gametes, whose developmental competence can be tested objectively. And so their combined work of Cell 2011, Science 2012, Nature 2016, and Science 2021, and Nature 2023 forms the technical and conceptual foundations for today's worldwide research in the in vitro gametogenesis. It remains the model by which every laboratory, ethic board, and regulatory discussion measures progress in this particular field and in the field of IVF in general across the globe. Let's go through the history and scientific foundations of IVF, IVG, and IVES. And let's start at the very beginning and work our way to the present time. Now, please don't take offense by the way I will just be wording this very matter-of-factly, clinically speaking. Whether it's ethical or not, it's not. And that's not up for debate. But I won't be nuancing that throughout the entirety of giving you the history and scientific foundations of this. So please don't come at me for that. Know it up front. Buckle up. So let's get into it. The in vitro fertilization, that is an abbreviated IVF, marked the first practical success in assisted human reproduction. The work began in 1950s and 1960s with laboratory fertilization experiments in rabbits and humans. And it culminated on July 25th, 1978, when Louise Brown was born in Oldham, England. Her birth followed years of collaboration between Robert Edwards and Patrick Steptoe and Jean Purdy. Edward later received the 2010 Nobel Prize in Physiology or Medicine for developing IVF, the first pregnancies confirmed that fertilization outside the body, followed by uterine transfer, could yield healthy children. Now, throughout the 1980s, IVF expanded from isolated research into clinical medicine. In 1984, scientists in Melbourne, Australia, reported the first birth from a cryoreserved embryo, an early step towards embryo freezing and storage. And by 1990, clinics introduced pre-implantation genetic diagnosis, later called pre-implantation genetic testing, which allowed biopsy of embryos to detect specific genetic traits before transfer. These so-called milestones turned IVF into a repeatable laboratory process and established the precedent that early human development could be studied, manipulated, and selected under controlled conditions. Now, during 1990s and 2000s, scientists learned to grow and freeze embryos at the blastocyst stage and to use intracytoplasm, sperm injection, and abbreviated ICSI, ICSI, for cases of male infertility. IVF became a foundation for reproductive biotechnology and created the environment in which the next frontier, as they put it, making gametes themselves in the laboratory, it could emerge. The term in vitro gametogenesis is abbreviated IVG, refers to creating sperm or eggs from pluripotent stem cells derived from ordinary somatic cells. Researchers reprogram a skin or blood cell back to a flexible state, then guide it towards the germ cell lineage. The first step is induction of primordial germ cell-like cells, or PGCLCs, which resemble early embryonic germ cells. From there, the oogenesis produces oocytes, and the spermatogenesis produces spermatoza, which stage requires accurate meiosis to half the chromosome number and precise imprinting of parental gene marks. Now, the modern IVG era began in mice. Professor Mitanori Sayato in Kyoto University and Professor Katsuhiko Hayashi, that we mentioned earlier, they developed a reproducible path from mouse pluripotent cells to functional gametes. Sayato's group in 2012 generated the PGCLCs from mouse embryonic and induced pluripotent cells through an epiblast-like intermediate. And then when these cells were combined with fetal ovarian somatic cells, they formed oocytes that matured, were fertilized, and produced live offspring. And that achievement proved the entire female germline could be rebuilt outside a body. Hayashi and collaborators expanded the protocol to spermatogenesis, and in 2023 reported functional oocytes derived from male mouse cells. After fertilization and transfer, the oocytes produced healthy pups with normal chromosomes. Although the efficiency was low, it showed that the sex chromosome barriers could be reprogrammed and in vitro, and the cell identity was remarkably plastic. And these mouse discoveries established the concept that the pluripotent cells could generate functional gametes, and that each step, specification, meiosis, and maturation, could be tracked and tested in culture. The research also defined standards for molecular markers such as SOX17 and BLIMP1, expression used to verify gem cell fate. Within just a decade, these methods were adapted to human pluripotent cells for study purposes, though not for reproduction. Parallel to IVG related field called in vitro embryogenesis or in vitro embryo synthesis developed. This term, often shortened to IVES, describes laboratory formation of embryos either from a lab-made gametes or from stem cells that self-organize like embryo-like structures known as synthetic embryo models. And in 2023, researchers reported human both implantation embryo model cultures to day 13 and 14, and that they displayed the major cell lineage and organization of a natural embryo. And these structures were not implanted and served solely as research models to study early development and infertility. I hope that they didn't go further with that. As these scientific advances emerged, policy and bioethics organizations began to expand. The International Society for Stem Cell Research, the ISSCR, issued guidelines that explicitly forbid transferring embryo models to any uterus of any species and require oversight for work on human IVG cells. In the United Kingdom, the Human Fertilization and Embryology Authority, the HFEA, recommended in 2024 that Parliament consider extending the legal research limit from 14 days to 28 days because modern cultures now survive longer in vitro and offer important medical insight, they claim. The recommendation did not change the law, but signaled that existing regulations may soon be re-examined worldwide. So we're headed real quickly into human clinical trials. The United States, the National Academies of Science, Engineering, and Medicine held a landmark workshop in April 2023 titled In Vitro Derived Human Gametes as Reproductive Technology. The chair was Dr. Eli Adachi of Brown University. The meeting outlined scientific milestones, ethical questions, regulatory gaps for IVG. It concluded that human application remains premature and that U.S. law would require Food and Drug Administration approval for any clinical use of in vitro derived gametes. Human IVG research to date has achieved reliable production of human PGCLCs from induced pluripotent stem cells and demonstrated partial progress towards meiosis, but it has not yielded mature maturation. It has not yielded mature fertilization-ready human gametes. These studies remain basic research tools used to understand germ cell development, epigenetic resetting, and infertility. At this point in time, no country permits their use for human pregnancy. Praise God. We know that that's neither here nor there. Now, they've already created the human being. It doesn't matter if it's been implanted in somebody's uterus or not. You're a human being, whether you're in a uterus or not. Anyway, so by 2024, the Institute of the Advanced Study of Human Biology in Kyoto, directed by Sayatu, reported enhanced culture conditions that allow human germ cell precursors to undergo broader epigenetic reprogramming and the expansion towards prospermatogenia and pro-oogenia, and results mark an incremental step, but not functional gametes formation. A 2025 systematic review of female IVG in humans and non-human primates found progress towards meiotic entry, but persistent gaps in maturation and functionality. Together, these data show that the human process is biologically more complex than the mouse model. Duh. So let's get into the human research part of it, the global regulations, and the current state of it. In late 2024 through 2025, several research programs extended the groundwork of the in vitro gametogenesis and in vitro embryo synthesis. These developments classified what has been achieved in mammals, what is under exploration in humans, and how international law is adapting. At Oregon Health and Science University, scientists published a nuclear transfer experiment called mitomyosis. In this approach, a skin cell nucleus was inserted into a donor oocyte, whose own nucleus had been removed. And then the cell was chemically induced to discard half of its chromosomes, producing a haploid set before fertilization. Of 82 fertilized oocytes, approximately 9% reached the blastocyst stage by day 6. Most embryos exhibited chromosomal abnormalities, and none were transferred for gestation. The work was reported as a proof of concept to study meiosis and chromosome segregation in human cells, not as a reproductive method. We know what they're going for, though. The goal is reproductive, though. So during the same period, a private company called Gameto advanced a different technology named Fertilo. Fertilo employs induced pluripotent stem cells derived ovarian support cells, abbreviated OSCs, to assist in vitro maturation of a woman's own immature eggs retrieved during standard IVF. The goal is to shorten hormone stimulation and improve egg quality. In 2025, the United States Food and Drug Administration cleared this product for a phase 3 trial under an investigational new drug application. It is the first iPSC-based biologic in reproductive medicine to reach that stage. Fertilo does not create eggs or sperm from somatic cells. It enhances maturation of existing oocytes. The phase 3 design includes collection of immature cumulus oocyte complexes. So the co-culture with OSC's fertilization, blastocyst formation, cryopreservation, and later transfer per standard IVF procedure. As these programs advanced, human IVG itself remained preclinical. Laboratories worldwide continued to generate human primordial germ cell-like cells and to drive them partially towards gametogenesis, yet no study produced fertilization-ready human gametes. Work in non-human primates yielded similar partial success, demonstrating meiotic initiation but not completion. These findings appear in the 2025 systematic review and now analyzing female IVG in humans and primates. Legal frameworks differ by nation. In the United States, there is no specific federal statute governing IVG at this time or embryo model research. Oversight comes from the Food and Drug Administration, yikes, and the National Institute of Health funding restrictions, gross, and then state level policies. Federal law at this time prohibits the FDA from reviewing applications involving heritable genetic modifications in human embryos, a constraint that would also cover IVG derived embryos. This restriction functions as a de facto ban on any attempt to implant embryos made from in vitro derived gametes. So the FDA has their hands tied, at least a little bit, thank God, at this time still. The United Kingdom operates under the Human Fertilization and Embryology Act, which currently enforces a 14-day rule limiting embryo culture. The Human Fertilization and Embryology Authority, the HFEA, recommended in 2024 that the limit be extended to 28 days to accommodate embryo model research. The proposal remains under parliamentary consideration. The Nuffield Council on Bioethics in London support further public dialogue and stronger governance of embryo models, noting that such structures could increasingly resemble early human embryos. They are early human embryos. The smartest people on the planet aren't so smart sometimes. So in the European Union, regulation occurs primarily through the Oviedo Convention on Human Rights and Biomedicine of 1997, which forbids creating human embryos for research purposes in signatory nations. Member states interpret this differently. France, Germany, and Italy maintain strict prohibitions, while Spain, Belgium, and the Netherlands allow controlled research under licensing systems. The European Court of Justice has also ruled that the techniques creating totipotent human cells fall under the embryo protection laws, a decision that influences stem cell research across the bloc. And so in Japan, where many IVG discoveries originated, regulates reproductive cell derivation under its Act on Regulation of Human Cloning Techniques. This law prohibits implanting embryos derived from human-induced pluripotent stem cells into a uterus, but allows laboratory culture of such cells for research. The Ministry of Education, Culture, Sports, Science, and Technology, commonly called the MEXT, the MEXT, issues permits for IVG-related work. WPI Ashby in Kyoto operates under this framework as well, focusing on fundamental germ cell biology rather than clinical application. And China's approach to reproductive biotechnology combines state regulation with rapid laboratory expansion. Guidelines issued by the Ministry of Science and Technology classify human IVG and synthetic embryo research as high risk and subject to central approval. Implantation or reproduction using such materials is forbidden, yet research and using stem cell models of early embryos continues under supervision at institutions such as Tsinghua University and the Chinese Academy of Sciences. Chinese researchers have produced embryo-like structures from monkey stem cells that develop to early post-implantation stages, paralleling human model work. At the global level, UNESCO's Universal Declaration on the Human Genome and Human Rights in 1997 affirms that human dignity must prevail over scientific interest and genetic manipulation. The World Health Organization, in its 2021 to 2023 Human Genome Editing Governance Framework, classified IVG within emerging reproductive technologies requiring international monitoring. The WHO Advisory Committee continues to review developments annually. Like we trust anything that organization has to say or do, right? In April 2025, the International Society for Stem Cell Research, the ISSCR Ethics Committee, released updated guidance clarifying justification for research involving human pluripotent stem cells and embryo-like structures. It emphasizes rigorous oversight, transparent reporting, and clear separation between basic research and clinical intent. The new statement aligns with earlier prohibitions on implantation of embryo models and strengthens recommendations for international registries of IVG studies. Now, beyond legislation, a sociological research began addressing how the public perceives IVG. A 2025 qualitative study published in Social Science and Medicine explored attitudes towards gamete and embryo creation through IVG, finding that perceptions vary widely by culture, religion, and familiarity with IVF. Participants tended to distinguish between therapeutic use for infertility and speculative reproduction redesign, expressing concern about the commercialization and identity implications. A separate analysis by WCG Clinical reviewed the global regulatory landscape for IVG. It found that most nations rely on existing embryo and stem cell statutes rather than IVG-specific laws. The report noted that regulatory clarity lags behind laboratory capability and that international cooperation will be necessary to prevent cross-border reproductive tourism once functional IVG becomes possible. In Europe, the Council of Europe's Bioethics Committee, DH-Bio, has begun consultations on whether IVG and embryo models fall within the scope of the Oviedo Convention's embryo clauses. Preliminary opinions suggest that they do, given their potential for human development. These discussions illustrate how international bioethics laws is evolving in real time. And the current scientific status in 2025 can be summarized precisely. In animals, IVG has produced functional eggs and sperm that create healthy offsprings in human, and germ cell induced is reliable, but full meiosis, imprinting, and maturation remain unresolved. Embryo models derived from pluripotent stem cells can self-organize to about 2 weeks of development, but cannot and may not be implanted. Claims of human IVG pregnancies are unsupported by any peer-reviewed data or regulatory approval. Knowing how the world is, though, I can just imagine there's some mad scientist somewhere in the trenches trying to do that. I don't claim that they are, but I can just imagine that they probably are. Future projections remain speculative. The United Kingdom's Human Fertilization and Embryology Authority has estimated that IVG for human gametes might reach clinical feasibility within 5 to 10 years. Adachi has said the same. Within 10 years, people are going to have their babies, and boom, just like that. Depending on biological and regulatory processes, many experts considered that timeline optimistic given the complexity of human meiosis and the ethical scrutiny surrounding germline manipulation. Technically, the field still faces hurdles in achieving faithful chromosome pairings and preventing abnormal chromosome numbers, reestablishing parental imprint patterns, and demonstrating the long term stability of resulting gametes. Researchers also continue to study mitochondrial inheritance, as mitochondrial carryover for somatic cells could affect embryo health. So, the scientific path from IVF to IVG and IVES spans nearly 50 years of progress, if you can call that progress. IVF moved reproduction to the laboratory. IVG seeks to move gametogenesis itself into culture. In mice, the complete cycle has been achieved. In humans, only early stages and steps have been replicated, and the strict laws prevent clinical use at this time. The global consensus across the United States, Europe, Japan, and China forbids implantation of embryos created from the in vitro derived gametes or embryo models at this time, and research remains confined to the laboratory under their ethical oversight. Now, let's get into what they consider ethical oversight. It's not. This stuff is demonic. These people have every intent, and they say so, that they want to be able to have two males have children together without the need or use of a woman. They said that even in 10 years, they'll still have to use another woman's uterus. This is just God-hating science. It's not God-hating science. It's these people are God haters and they hate science. These people hate God and they are mad scientists. Plain and simple. This stuff is demonic. We need to get involved in this conversation. This conversation has to be had. And I'm hoping that this series of these podcasts are going to help contribute in helping you become more literate about the subject matter, the words that they use. This is real super basic stuff. This is entry level information. This is to slowly integrate fellow brothers and sisters in Christ into the conversation. Let's get you in here. Let's get you familiarized with what they're doing, how they're doing it, what the words mean, and let's get you up to par. So you can vote when you have a chance to vote, where you can sign petitions where you have a chance to sign petitions, where you can go and fight this, because the fight is not just in front of the clinics. This fight is here. It's in the universities. It's in the laboratories. The fight is here. We need to have believers who are educated. We need believers who are in the medical field already, who are nurses and scientists and doctors and professors. We need them to get into this fight because this is where they're going to feel the pushback, is where they're at. They need to feel that pushback in the classroom, in the laboratory, on these boards of oversight committees, etc. The fight needs to go there. We need other academians and we need other professionals and scientists to come aboard the abolitionist movement and start speaking into these matters as part of the peer reviewing, as part of their peer groups. I think it's important. I'm hoping that will happen. Thank you for joining me. This has been the Mercy Fields podcast, number 8 of IVF, IVG, and IVES. And I pray that the Lord would move you to get involved, to educate yourself even further, and to like, follow, share, comment, share this with your friends. Hop on over to Patreon, give us some support, and help us go from these basic entry-level podcasts into getting into deeper, more entailed information, and bringing people into the conversation where they could be useful in fighting against this even more than they are already. So with that, thank you, and all glory Christ.